Okay everyone, my name is Mason Lane, and today we will be learning about atomic trends. So go ahead and get out your periodic table, and then we can begin learning. Okay, now that you should have your periodic table out, the first thing we'll be learning about is atomic radius. And the atomic radius is the size of the atom, and the atomic radius decreases as you move from left to right across the period. And the reason for this is because each proton that you add to the nucleus draws every other proton in closer together. So say if we have lithium and nitrogen, nitrogen is smaller than lithium because lithium has less protons and nitrogen has more, so nitrogen pulls in the protons closer together, thus making it smaller. And then the atomic radius also increases as you move down the group, because each time you add an energy level, the size of the atom increases because there's more electrons spinning around it. So sodium is larger than francium, francium is larger than sodium because francium has 4 more energy levels than sodium. Alright, next on the list of periodic trends is the ionization energy. We're going to skip around. The ionization energy is the energy required to remove an electron from an atom. And the way that you can think about ionization energy is how tightly the nucleus holds the electron to the atom. So whenever we look at our periodic table, ionization energy increases as we move from left to right. So an atom of potassium has less ionization energy than an atom of bromine, because bromine has so many electrons surrounding it. The nucleus just does not want to give away all of those electrons, but potassium, the bond around the nucleus for the electron is weaker because there's only one of them. So that's why potassium tends to give away its electrons rather gain them. And then whenever we move up and down, whenever we move down the group, the ionization energy decreases. So that means that it is less difficult for an atom to give away its electrons. So if we look at cesium and francium, cesium has 1 less energy level than francium. So that means cesium, its ionization energy is lower than francium's, because francium's energy level, it has 7 energy levels, and so that means that the outermost shell of electrons is further away from the nucleus, making the energy needed to pull it off of the nucleus smaller than that of cesium, because the electrons of cesium are a lot closer. So that means francium is a lot easier to remove electrons from. Okay, third on the list of periodic trends is electronegativity. Now basically what electronegativity is it's the tendency in which an atom will attract electrons to itself. So if we look at, say, group 1, we know that these atoms are basically not electronegative, because they don't attract any electrons, they give them away. So electronegativity increases when you move left to right across a period. And see, if we look at the halogens, which are the most electronegative on the periodic table, we know that they all have 7 electrons in their valence shell, and they all need just 1 more electron to fill it. So they have a much higher tendency to attract an electron than, say, potassium or sodium or other atoms like that. And so electronegativity increases when we move from left to right. And then also, electronegativity decreases whenever we move down a group. And the reason behind this is because the further the electron is from the protons in the nucleus, the more difficult it is to attract electrons to it. So iodine is less electronegative to fluorine because there are more energy levels to it because it's further down in period 5 while fluorine's in period 2, and so it is harder for iodine to receive and attract electrons, whereas it's very simple for fluorine because it has such a positive force pulling inward on other atoms to where it is able to accept those electrons. Okay, so finally, today the last periodic trend that we'll be looking at in this video guide is ionic radius. Now, ionic radius and atomic radius are very similar in the way they work across the periodic table. And so the ionic radius is basically the radius of an atom's ion. Now, we need to remember that an ion is an element that either gives or loses an electron in a chemical reaction. And so, like I said earlier, ionic radius is very similar to atomic radius in the way that it works across the periodic table. So whenever we look at the periodic table, that ionic radius decreases whenever we move from left to right. So sodium will have a much larger ionic radius than chlorine, because whenever chlorine is an ion and its valence electron and its valence electron cloud is full, or its valence energy level is full, the electrons are packed more tightly towards the nucleus because of the protons in the nucleus pulling the electrons toward them. And then so whenever we move from top to bottom, it's the same concept. So for fluorine, the when the ionic radius increases going down. And so whenever it goes down, that means the atom gets larger and larger. And so essentially whenever we move down, an energy level is added, thus making the nucleus and the electron clouds further away from each other. So iodine has just a slightly bigger nucleus than bromine because it has one more energy level, one more energy level than iodine. Iodine has one more energy level than bromine, making it just a tad bit bigger. Now, the last thing that we'll be doing today on this video guide about periodic trends is I will give you two elements, and then you will write down which is more of the two, and I'm going to give you a trend to apply to each of these elements. So, if you need to, whenever we're doing these, go ahead and look back up to your notes and refresh your memory on the trends, and let's get started. So which of these two elements has the larger atomic radius? Sodium or chlorine? So go ahead and jot down whichever one. Now the correct answer is sodium, because if we remember the trend, the atoms get smaller as you move across left to right across the period, because the more protons there are, the more attracted they are to the nucleus, and they get pulled in tighter and tighter and tighter. So the correct answer would be sodium is larger. And then now let's do electronegativity. And which of these is more electronegative? Beryllium or strontium? And then, if you remember correctly, electronegativity decreases whenever you go from top to bottom. So that means beryllium is more electronegative than strontium. And then lastly, let's do ionization energy. And ionization energy is the force required to remove an electron from its valence shell. So let's do potassium and bromine. So which of those two requires more ionization energy, potassium or bromine? And the one that requires more energy is bromine, because ionization energy increases whenever we go from left to right across the period, because potassium only has one valence electron, so that means it's very easy for another element such as a halogen to swoop by and grab the electron from it, whereas bromine has 7 it has 7 electrons in its valence shell, so it's very hard to take one of those electrons away. And remember to fill out the summary at the bottom of the video guide sheet and write a question that you may have, and thank you for watching.